Okay, I've been asked to go over the celebrity wedding and just talk through um, how this kind of plays out, especially the end part of how we actually end up with the solution that we end up with. So, what we're wanting to do here is we've got uh, a wedding which is located at the origin, 0, 0. We've got a no-fly zone because it's a celebrity event and we don't want people flying directly over the wedding party. And it's quite a large one as well. It's 15 kilometers in every direction. We've got a road that actually originally went through the middle of the wedding party, but what we're going to be doing now, of course, is um, going to have flights that they're going to go over it. But they can't go over the actual wedding party itself. They have to go on either side of the wedding party. So either over here or on this side over here. But the one criteria the pilot has to follow is that he or she has to have the same gradient as this road. And the gradient of the road, we're told, is 2, because it's y equals 2x plus 10. 10, of course, is the intercept. Intercept means it's going to be crossing at 10, because this, of course, is the y-axis. This is the x-axis. So there are 2 possible flight paths. One is over here, and the other is over here. But the flight path can't touch the circle. They've got to be on either sides of it. They've got to be on either. So it could be here or here or here, or it could be here or here or here, but they have to be parallel with this. So whatever this is here, these have to be parallel, yeah? Whichever flight path they take. But they can't fly down here, they can only fly on either side, and they can't touch the no-fly zone. They've got to be outside the no-fly zone. And that's how we're going ahead with it. So how do we actually calculate that? All right, so to calculate this, we know that we've got a circle, and the circle in this case is this one here. It's y is equal to, x plus y. The circle, so it's x plus y squared, is 225. And we also know we've got a straight line that's going to go somewhere here. And that straight line is going to be y is equal to 2x plus 10. But it can't be 2x plus 10. It's got to be something else. And we know the gradient remains the same. But what we know is the intercept won't be the same, because these intercepts here, these are going to cross somewhere way down here. And this one up here is going to cross somewhere way up here. The question is, what is the intercept here? What is the intercept going to be here? And that's what we've got to find. So to find that, instead of writing the equation of the line with the intercept of 10, we're going to take that 10 off, and we're going to change it. I'm going to change it to a value of k. So now what I'm going to do is I'm going to recalculate this and look for the points where this and this meet. In other words, we're going to use simultaneous equations, but rather than to put this with a 10 into this equation, we're going to use a k. So let's do that now. Let's have a look. So I'm going to have, let's see, I've got x squared plus y squared plus, sorry, my bad. Like all these things, I'm doing it off the top of my head a bit. So 225. And this y squared, I'm going to now insert this bit into the y squared here. So let's rewrite that now. So we're going to end up with x squared plus, let's have a look, y squared, which is 2x plus k, all squared, is 225. Now this is squared, so I'm just going to have 2 of them, yeah? So I'm going to have x squared plus 2x plus k times 2x plus k equals 225. Now, this next bit, I want to actually subtract 225 off both sides. And there's a reason for this. What I'm wanting to do is make it equal 0, because this is a quadratic. This isn't the discriminant or anything. Remember, the discriminant really is only used for one thing, and that is to say, if we've got a quadratic and we don't have integer values as coefficients, I'll tell you what I mean. So let's say, for example, I had x squared plus 2x plus 3. Yeah? Let's say that was my quadratic. Well, I can see my coefficient here. Or let's make this 4x. Yeah? So the coefficient of x squared is 4. The coefficient of x is 2. And the final coefficient is 3. So I've got whole number, or I've got natural or integer values as coefficients. But what say I got 4x squared plus 5x plus k? Or this wasn't 5, this was k. Yeah? Or this wasn't 4, this was k. Suddenly, I don't have an integer value as a coefficient for some of these items, or all of the items. Now I have to use my discriminant in order to reveal what these are. And I can reveal them if I know what this equals. And if it equals 0, then it means I can solve it. But right now, we're going to have a look. There's a quadratic. It's not our quadratic. This is all nonsense. But I'm using this as an example to show the reason we use the discriminant is simply to reveal what the coefficients are of the x values when we don't have integer values. Here we have integer values, don't need discriminant. Here we don't have integer values, we need to use the discriminant, and the discriminant will reveal the value or the range of values that these occupy. All right, so we've still got our quadratic equation. Here it is, and I'm going to expand it out a little bit. So let's take a look at how that would kind of play out. So we're going to end up with, and I'm going to have, let's have a look, x squared plus 2x times k. Right. In fact, I'm just going to fast track this. You know how to multiply all that out, I'm sure. I'm just going to write all that out, which would be 4x squared plus, what's that going to be, 4 and 5, 4kx plus x squared minus 225. All right, and this all comes to x squared is going to be 5x squared plus 4kx plus, and we've got this bit on the end here, which is rather annoying, k squared minus 225 is 0. All right, what does all that come to? Well, there's my quadratic, and my quadratic is annoying because it doesn't have integer values. It's got one of the values is 5. Good. Tick. Integer value. But this is 4k. That's not helpful. And look at this last one here is all of that. K squared minus 225. The c value, by the way, will always be what's left. So here's my a value, here's my b value, here's my c value. So what do I do with all that? Well, we're going to put it into, we're going to have to use the discriminant to reveal what these values or the range of those values in fact is. If this quadratic equals 0. That's what we're doing. So let's use b squared minus 4ac, and we can say it's less than 0. By the way, the reason we'd say it's less than 0 is because equals 0 would be 1 point of intersection. Greater than 0 would be 2 points of intersection, but we want no points of intersection. So if it was going through the middle here, there'd be 2 points of intersection, and I would go greater than 0, but it's not. All right, so let's have a look. So I'm now going to go, well, what's b? Well, b is going to be 4k squared, all squared, minus, what have we got here? 4 times 5 times, this would be k squared minus 225, and that's going to be, well, I won't say less than 0. We could do, but I'm just going to go equals here, yeah? So what have we got here? Let's multiply all this out. It's going to be 4k squared minus, this is going to be 20 brackets k squared minus 225, and all that equals, what have we got here? Well, 4k squared minus 20, I'm going to actually expand this out, so this is now 4k squared minus 20 times that is going to be 20k squared times, negative 20 times negative, that is going to be, and I think we decided that was going to be 4,500. Fantastic. Well, 4k squared minus 20k squared is going to be, that's going to be, sorry, that was in brackets there, yeah? So this now is actually 16k squared minus 20k squared. Now that makes it easier. 4,500, I was wondering what I was doing there. So 16 minus 20 is going to be negative 4k squared plus 4,500. Notice there's no k to the 1 we just goes straight from a k squared to a k to the 0, if you like. So I'm going to take that into the calculator, and I'm just going to reveal straight away what that would be. Let's have a go at doing that. Let's have a look. Menu. Oh, crikey, where's my thing? Here we go. So I'm going to go exit. Here we go. So here's my calculator thingy. This is where I'm going to see if I can reveal what some of these values are going to be. And this is really what we're doing now. So we're going to go menu. I'm going to go 8. I'm going to go polynomial. Oh, no, we're going, polynomial solve, which will be 2 degrees. And let's see what this is. So still got stuff from last time. Let's see. Okay, so it's going to be -4. Put -4 into there. There is no b term. Oops. No b term. I'll cursor along. And the next one is 4,500. Oops, too much. Let's see what that is. Okay, so I'm going to go solve. And I get 33.541. So I got positive. So k, so this is either k is equal to 33.541 or equals -33.541. Well, what have we found here? We found the intercepts. So this is what we found. So the intercept's either going to go all the way up here and cross at 33.541 or crossing down here at -33.541. That's what that means. Okay, so what you need to say, I think, here is that you found intercepts. So in other words, the equation, and you want to say, therefore, the equation of the flight path must be either, and you could say y is equal to 2x plus 33.541 or y equals 2x minus 33.541. Yeah? So you want to actually put this in as part of your solution. The other thing, of course, which I would do in this point, is that it's perfectly reasonable to draw the parabola, because this thing is actually a parabola. If you think that k is an x squared, then you're going to end up with something that looks like this. Yeah, you got your parabola, and you know you've got 33 over here. I'll call that 33.541. And this is -33. Now, the reason you draw this is for one reason only. Because when you draw this, and look, it's a negative parabola, which means it's just going to go straight up like this and round and down. That's what it's going to look like, yeah? That was very poorly drawn. Oh, dear. Not good. All right, so let's have a look. So this being the case, what we see is that we have a positive portion going up, yeah? So this bit here is all positive. Positive is above the x-axis. Negative is below. So in this case, the negative values are all down here. These are all negative values. So why does this matter? It matters because we want to find this when this equation here is less than 0. Well, where is less than 0? Well, greater than 0 is above the axis. Yeah? Well, let's check. Let's choose a value. What about this value here? Is that value greater than 0? Yes, it is. Is this value here greater than 0? Yes, it is. What about this value here? Is it greater than 0? Oh, there it is. What about this value over here? Yes, it's a greater than 0. What about this value here? Oh, no, it's not. What about this value here? Oh, no, it's definitely not. Yeah? What about this value over here? Oh, no, definitely less than 0. So above, the x-axis is greater than 0. Below the x-axis is less than 0. And well, the question is, well, so what? What it means is the range of values for which this will be true, that is, this equation here is less than 0, will be on either side here, because all of these values here are all less than 0. So it must be less than negative 33.51. Yeah? So we could say the value of the, in fact, let's have a look. Yeah, actually, I'm looking at this here, and I actually wouldn't say, so why is this? We actually want it to be less than that. So I would actually say either y is less than this thing here, or y is greater than that thing there. And now that would be true. So I would actually have here, yeah, I'm just trying to think the best way to actually express this, because I'm wondering the way which they would want the answer to be portrayed. Now, I'm just going to have a look. I haven't actually got what I had last time. You see, I don't have the piece of paper that I actually wrote on. It's all been sucked into the ether somewhere else. But the long and the short of it is, I would say, and it's all out of focus. Why does it go out of focus? In focus, please. In focus. Thank you. All right. I would say that the values of k of the intercepts. So this is what I would say. Therefore, the values of the intercepts of the equation y equals 2x plus k must, I would put, in fact, I'm going to write off something. I'd say the values, yeah, sorry, this is not very clear, but the values, and I'm just thinking on my feet, you see, I'm thinking of the, that's what, flight path equation. I would put must conform, and I write the equation now, y equals 2x plus k, must conform, I'll use a sharper pencil, conform to k, and this is the important bit, yeah? I would definitely put this, k is less than negative 33.54, or k is greater than 33.54. Is it 54? Yeah, 54. I make it 3dp, and I put 3dp here as well. 3dp, yeah. And you might put so that the plane does not cross or touch both, yes, the no-fly zone. Now, I've said this in lots of different ways in this time, and the reason is I'm just trying to tease out the best way to think about it. But I'm thinking about it, I think, the way which you should think about it, and this is what I would say. So hopefully that's been useful. I don't mean to confuse you with all that nonsense, but I would actually conclude by saying that. But the reason we've chosen these values here is simply because when we draw the parabola and this equation being less than 0, well, less than 0 values are the underneath values when the parabola drops below the x-axis on either side, and so there must be anything from here onwards or anything from here onwards, and that is why. So that's the way I would express that answer, and that is why. Hopefully that's been useful. I don't mean to confuse. Get back to me if you've got more questions, but thank you for those questions. That's very cool.